We're good? Alrighty. We're going to get started. All right, so I wanted to start off by saying I'm really, really excited to be here. First DerbyCon for me. I don't know how many of you guys first DerbyCon? Yeah, good times. Excellent. So yeah, let's get into this. In essence, the talk is about DDoS. So we're going to be talking about some new vectors, some exploitation type stuff, and it's going to cover a wide range of things. And it's focused on really the penetration tester and really being able to demonstrate the risks in testing in DDoS. So let's get into this. The first thing, we need permission before we do any sort of DDoS, right? This is a really critical element. So thank you for taking notice of this notice here. Feel free to take a look. Alrighty. So the talk, the agenda, we're going to start off by talking about sort of some industry trends, set the stage for the rest of the talk, and then from there we're going to go into some details about specific vectors that we've found to be successful, as well as to sort of expand the current methodology and toolkits to be more distributed in nature, because that's really where we found some limitations in existing toolkits capabilities, is on making this stuff fully distributed, as well as putting it together so that you can leverage it in a real engagement. So first off, who am I? So my name is Josh Abraham, also known as Jabra, for many of you guys who know. I run the services team at a company out of Austin, Texas called Praetorian. We do application penetration testing, network penetration testing for many Fortune 5000, Fortune 1000 organizations, pretty much across the board. I also do some high techs and financials. I've done a lot of presentations at a lot of different conferences, Black Hat, DEF-CON, pretty much everything around the board. I do a lot of coding in Perl, so if you guys are Perl guys, let me know, as well as Ruby, which you guys will see in this talk. So we're not really here to talk about that. What we're really here to talk about is the landscape today and where we see things going. Currently, what we're seeing is a lot of clients will come to us and say, we're having problems, we want to test our security, and we're focusing in on the confidentiality or the integrity of the data. This is really what we see a lot. We see this every day, all the time. People are not really focused on the availability testing, right? Maybe they're doing it before they get it to us, or they're just not asking for it. But what we're seeing really is that there's not a lot of tools out there that help clients understand what would it be to do a test that is going to test your organization from the highs to the lows across the board in terms of DDoS. So it's sort of like an ad hoc process. So we put together a methodology for everybody to make this a little bit easier. So starting out, one of the pieces that we actually looked at initially was a vulnerability that we actually ran into in a pen test. And this was a PHP vulnerability which gave remote code execution, right? We see this all the time, but why this is actually interesting was this actually was leveraged in the wild to do a distributed denial of service, right? And even though it's a vulnerability from several years ago, it's still being utilized in the wild today. 2013, 2014, like this is relevant and still being used. So it's PHP vuln, but it gives you code execution. We all know about the bash bugs that have been released recently, so it sort of falls into the same bucket. If you can get code execution, what do you use that code execution to do, right? And what we're seeing is they're going to use it for DDoS. Very, very prevalent. So a quick proof of concept with curl and bash put together looked like this. Not very exciting or fancy. And then converted it over to a Metasploit module. And again, all of this code is already online, and you guys can go and read about the blog post for how you could create a similar vulnerability or demonstrated the exploit. So vulnerabilities are existing, they're being utilized to perform DOS, and what are we seeing in terms of metrics for denial of service? So here are some of the metrics out of a recent DDoS-based report. So we have an uptick in certain types of based vulnerabilities. UDP floods are way up, right? 300 gigabits per second. So this is really where people are going for the high bandwidth, right? And we're going to talk about how that actually is conducted in the next section. But an interesting trend here is that there's been a significant increase in the reflection-based attacks, right? And what that is really, we're going to go into it in great depth, but for now it's just a indirect communication to your target system. And it's going to be using NEP in this particular example. So let's talk about some different types of threats. So you could just have like a traditional flood of bandwidth, right? We're going to just flood the pipes and just saturate all the network connections and just lock them down that way. That's very unsophisticated, but it works, right? It works, and that's one route. The problem is it requires you to have bigger pipes than the target, right? And not everybody has 100 gigabit connection just sitting there. If you did, let me know, that'd be great. What more often happens is you take a look at the application and really break down that code base to say, let's attack the application as it lives and try to see if there are some weaknesses and interact with this application in a unique way. And if we can bring it to its knees, not needing all of that bandwidth, it could be a cheaper solution. There are a lot of other different types of attacks here, but in essence, the summary of all of these is that any different piece, so whether it's your upstream provider that we want to attack, and that affects your availability, or maybe you have different geographic locations, and I just bring you down in one, that's, that could be what I'm trying to achieve. There's a lot of different ways we can actually conduct a DOS. This really just goes back to your threat model. Possibilities for attack, there's a lot of different layers here to go after, and it really just depends on, what do you have in terms of capabilities. And later on in the talk, what we have is we've actually compiled a menu. So based on your resources, you can say, all right, well, I'm going to attack them in this particular way, and we're going to map it back here. So really the summary from that is the high bandwidth attacks are not as sophisticated, but they do require the resource. The application layer attacks, way more sophisticated, moderate to high sophistication, but you do need a little bit more reconnaissance. Sometimes you even need authentication to the application, which you may or may not have. And both are really effective, but in theory, if you have DDoS-based protection controls, they might mitigate some of your attacks. Just some things to keep in mind here. So now what we're going to do is shift our focus towards really diving into these reflection-based attacks. So what this is so me, I'm a bad guy on the internet. I scan the internet. I try to identify vulnerable systems, and then I'm going to use those vulnerable systems to attack the target that I'm trying to affect. So what does this look like here? So the bad guy is using his laptop. He identifies an exposed service, and he basically does a spoof of the source IP address, and it says, hey, NTP service, yes, I am this guy over here, and the response to this UDP request will go to the victim, right? And so the attacker does a little bit of work. He sends a very small request, and the response is huge, right? Which in essence gives us the DOS. And if we do this a large number of times, and we're going to use, ideally UDP here, because it will give us, the ability to just send packets on the wire and just not care about the response. It just floods the system. And it really requires a couple of things. One, you need the vulnerable system or service to be exposed, right? And you have a lot of different services. NTP is one example. And then you also need the capability to spoof your IP address and to have it reach the target. So how does this work for us as pen testers, and how would this really work in the real world? The problem is for a pen tester to be able to spoof an IP address and use vulnerable systems on the internet, it doesn't really fly with legal, right? They probably will not approve this if I go to them and say, hey guys, we want to use vulnerable systems on the internet to DOS client X. Yeah, they're not going to be too happy with me. The boss is not going to approve that. He's definitely not going to look at that and be like, yeah. So instead, what we're going to do is we're going to use a couple of other approaches to really help clients mitigate this particular threat. The best approach that I've found with clients is to really just walk them through talking about the different threat vectors here, and really just pointing out the fact that, look, we need to understand what your capabilities are for your upstream providers. If you're using content distribution networks, what are those, and what are the controls in place to mitigate a flood of this type of scale? Because if you saw 300 gigabits per second hitting your network, you're going to get cut off there, and it's just as easy. So this is how we would actually do it. It would be more of a discussion-based approach rather than actually implementing the reflection-based attack using vulnerable systems on the internet. So to actually sort of illustrate this, we have a lot of different services that we could use. We could use NTP, we could use DNS, as we had mentioned. There are some other services. One of the really cool ones that we found is this thing called Chargen, right? And this is basically a service. Just a quick question. Does anybody know what port Chargen runs on? I heard somebody say it. Somebody said it. All right, well, one person said it. To be honest, it's a really antique service, right? So you send it, an A, and then it responds with a whole ton of data, right? This is ideal for doing a DOS because it's all UDP and you're just sending characters on the wire and it just floods the response, right? So this is perfect. So the amplification is really huge here, right? 359 as an amplification rating. NTP is the most with 557, and just the breakdown of what's going on here. So we compiled a little chart here, basically show the metrics and the numbers. So if you were to choose a specific service, which ones would you go for? And again, if we have systems on the internet, we can just scan for these blindly and just use them if we wanted to. The metrics are all coming from CERT and NIST, so definitely reputable sources. And then what we can do is we can just map these back to something like Shodan to figure out how many systems are vulnerable. And then if we were to utilize this is what the impact would be. So pretty useful here. One of the funny ones, if you look down at the bottom, the Quake protocol. I remember Quake. I mean, everybody played the old school games Doom, Duke Nukem, all that stuff. Quake service, kind of random, but definitely still out there. People are still using it. So NTP, right? How do we scan for this? This is a interesting use case where basically what you do is you talk to the service that's exposed and you say, tell me about the systems that you've connected to recently. And it basically just spits back a list of all of these different clients. And so what you can do is you can just use Nmap to do a quick query, and you'll get a flood back of, here are all the services or systems that I know about. And then where this actually got a little bit more interesting is I was actually looking and monitoring the Nmap or the Metasploit developers list. And one day I did an update, and John Hart, he had actually found a ton of different NTP-based vulnerabilities where you can use this particular same vector with a lot of different other variants to get increased amplification. So kudos to John for that. So what we did was we took this particular vector and we basically had weaponized it already in Metasploit, right? So he checked in the code, which would allow you to identify these different types of vulnerabilities using a distributed-based attack. The problem was there was one limiting factor, which was in the code. It didn't actually allow spoofing, right? And spoofing is the most important vector for when you want to do an amplification, right? I want to say I am, Google's IP and send it to the target, and then it amplifies, and then it does the spoof. So this is what it looks like. So I took all of the different modules in Metasploit and modified everything to basically support spoofing. And it really wasn't that long because it was just a quick change to one of the mixins. So all you need to do is just set the source IP to be, this is the system that we want to go after. And then the R host is the vulnerable system, right? So the vulnerable system is the one on the internet, and .61 is the one that I want to flood. And so when I send this request, it's saying respond to 61, and it gets flooded, right? And we do this for a lot of different modules, but this is the basic use case for all of the Metasploit modules that I modified. Then we did a quick look on Shodan to just get some rough numbers in terms of recursion. So recursion is, just instead of an NTP-based example, DNS-based example, tell me everything that your name server knows about, even if you're not authoritative for it. So it basically spits back a list of everything, and here's the number of systems that are on the internet based on Shodan, which have this particular flaw. It's sort of a misconfiguration in the service, but again, it's really great for doing what we want here. So a lot of systems in China, either intentional or unintentional. Maybe they were, hey guys, wouldn't it be great if we had more DNS servers? Maybe not. So similar to the NTP-based example, DNS-based spoofing, and we just set the source IP to 61, and we set the number of requests. So you could change this to be 100, 1,000, whatever you'd like, and maybe run it multiple times if you had multiple systems, and it would just run. Again, though, it does require the system to allow spoofing to basically forward on that traffic. So if it doesn't forward on the traffic, you're basically conforming to the best practice, the common best practice 38. So that's sort of a limiting factor here, again, to keep in mind. So coming back to the charge end service, this is basically what it looks like. You have a system or the service that we're just connecting to. Again, we're using UDP, and we're just sending an A, and then the flood on the bottom is all the data back. And so, I mean, this is ideal, right? Again, why this stuff is running on the internet, I have no idea. But we looked and Shodan, and I think that there were near 10,000 systems on Shodan which had this. I was like, for what reason? I don't know. So again, the charge-in based module. So we just load the charge-in, and then we just set the rhost flag and say run. And then the responses come back, and we say that's great. So this spoofing, similar to what we saw before, we set the source IP, and then just the number of requests, set it as 1, and then we'll just get the response. In terms of the comparison, just a quick TCP dump. So right on the right, this is the request. On the left, the response, right? Really just being able to demonstrate the magnitude of the data that's coming back. And one last example was the SSDP. This is just another service that we came into, and so there's a lot of spoofing as well, and worked out. All right, so that's reflection-based attacks, right? Where we're doing the spoofing of our source IP, sending it to a vulnerable system on the internet, and then it basically takes the response and sends it on to the person who we spoofed. Now we're going to talk about, we're going to go through specific direct access-based attack vectors. So what these are is, instead of using reflection to basically do any sort of spoofing, we're going to just connect to our targets directly, or maybe we're going to use Tor to basically go through Tor to do that type of connection. So the first attack vector that we looked at was one that came out in 2009. So this is a while ago from RSnake. And why this is even in the talk is because it's still useful today, right? You could set up an Ubuntu 14 LTS system and bring it down with one command. And it's fast. It's fast and it doesn't require many resources, right? It just works. So this is like, it's pretty ridiculous. It really focuses mostly on Apache and a few other web servers. But if that's what you're going after, it's quick. Why go with something, something else? It's been out for a while. The documentation's pretty good, and it's been tested. So this would probably be the way that I would go. The cool thing here is that the bandwidth requirements are really, really small. So even if you don't have a really large pipe, you can still send, and you can still have a lot of success. So it's a really great vector. And the way that it works is, in essence, it just keeps the connection header open, and it just doesn't shut it down. So it just sort of waits forever. It just sort of waits, and then from there, you just keep it going. So what we did was, for each of these attacks, we basically put together a pros and cons for them, so that it's sort of like a guide for, if I were doing this DDoS-based test, here's a couple of things that you'd want to keep in mind. So first, Loloris, it's great because it still works against Apache even today. The bandwidth is really, really low in terms of resources, so that's great. The cons, it's not always going to work if you have like a content distribution network in place, and some of the features aren't fully tested. But that's actually maybe even a good thing. You could jump in there, add some features. It has IPv6 support, so that's pretty awesome. So there's a lot of different ways you could use this, and Apache is very, very common, right? So hash collisions. So hash collisions, this is a really interesting one. This is where we start getting actually, some of the newer school-based attacks. So hash collisions, in essence, it's when we're actually talking to a specific application, so like PHP, for example, and we're sending it content, and that content is going to map back to the same hash. And in essence, having the server do a ton of work. It's going to have to look up all of these different values and in essence, they're going to map to the same thing. So it's just, it's going to kill itself. The problem here is that it's very specific to the version of the language that you're targeting, right? So we can't just go and, assume, okay, if it's running Apache, we can just fire this off. We need to know what languages they're running. So it does require a little bit more understanding of the target. So we put together just the listing here to make it really, really simple. So for Java, you're pretty much across the board. For PHP, specific versions. But I mean, it works on Python. It works pretty much everywhere. The interesting thing here is that it actually, the initial disclosure for this particular vector was back in 2003 in Perl. So a long, long time ago, they actually knew about this, and it sort of just came back to bite everybody else that hadn't mitigated the flaw. So that type of thing can happen a lot, and we should be looking for other types of vulnerabilities that might have been fixed in one language that would affect others, right? So that's definitely a good thing to keep in mind for developers. So yeah, I mean, this is affecting pretty much across the board and pretty much in a really, really bad way, because what in essence it does is it basically kills the memory of the system. So here's what it looks like. And yeah, this box is totally not coming back, right? So if you're on SSH, you're not going to be able to use that system. You're going to literally need to be consoled in and hope that you're also not running as root. Because if the web server is running as root, bad things can definitely happen. So the pros and cons for the hash collisions-based vector, right? So it affects a large number of languages, but many of them have patched this particular flaw. So if they're, so it can be a pro and a con. I think it's a pro because it has wide coverage. If they haven't mitigated this particular, if they haven't running the latest versions. It's a little bit harder to block than a bandwidth-based flood, which is really a pro for us as the attackers. Maybe a con for the defenders, whatever side or hat you wear. In essence, on the con side, though, it requires a little bit more research, right? We have to understand the application a little bit better. We have to understand where it's going to hit the database. We have to understand where the application is going to process that request and how that's going to work, right? So if they're static pages, they're not actually using that content, then that URL or that particular page might not be useful. But if we hit the right page and we get this content to be processed, then we're absolutely going to potentially cause this particular vector to execute. Lastly, it does require a bit more memory on the attacker side, so we have to be able to generate all of these different hashes. So that's just another thing to keep in mind. So when you're allocating systems, which we're going to talk about later in the talk, we need to keep this in mind so that the resources wouldn't just be one guy in Starbucks with his laptop. He might spin up a few systems additionally. Now, another vulnerability, sort of in combination with DOS, is one from the THC guys. They did some SSL-based DOS back in 2011, and so they put out this really cool tool. It's in essence, it uses the connections to a system when there is SSL to basically renegotiate that SSL connection. What this does is it basically forces the server to do a ton of work, and the client's just making a quick request. Right? It's really, really, really intensive on the server, not on the client. And that's where DOS comes in. So we looked at the code, and it was a great tool, but it had a lot of limitations. One of the main limitations was there was arbitrary wait delays. In addition, it didn't support lookups by hostname, so it would only use IPs, and it would do these arbitrary waits. This is not going to work for what we need, so we removed all of that. And what we also added was the ability for it to do a renegotiation over TCP if it was disabled initially. So this is a really great combination where we had to go through their code, basically fix it up a little bit and clean it, and we're going to be putting out this code so that you guys can take it and just, if you run into a system that might be vulnerable to this, have at it. Have a good time. So the THC DOS, the recommendations, it still works 3 years later, which is really great. It's highly effective against most configurations. The downsides are that if you're running content distribution networks, it probably won't work. But that's really the only downside. you'd be able to look for the number of requests, in terms of the renegotiations that are being made. And then if you see this number of IPs, you could just block them that way. So there are some easy ways to block people, but if they don't have any of those controls in place, you're probably going to win. The next vulnerability here that we used, this was an interesting logic, calling it a logic K-line, or where the system basically just dies. In essence, it was an application which did require authentication, right? So I had to communicate with the system, had to authenticate, get in, which you might not always have. But what it had was a unique session identifier, which we could regenerate from the attacker's side. So this did require a bit more knowledge of the application, and this is the actual communications that we were making. So we see in the cookie value right over here is that we can basically fuzz this particular parameter. And what we were looking for at the time was not actually a DOS, but we ran into a DOS condition during the test. And so this was something that was identified during our fuzzing session. And when you identify something like this, it's important to go back and say, wait, we found an interesting condition here that might not be, a traditional based, cross-site scripting, SQL injection, this type of thing. It could be something else, and really just go back and try to reproduce it to see if we could get something useful out of it, right? To get a DOS condition that was highly effective, and wow, was it effective. This particular flaw, in combination with the misconfiguration on the web server, where they were running it as root, which is not exactly, we'd be able to still get the same vulnerability out of it, it wouldn't have the same impact. If it's running as root, it's going to be much worse. What happened is we were able to send about 100 or so requests, and in essence, the server basically died. And when I say died, it basically was not accessible via SSH or console, right? It looks like this. It's dead to the max. And it was reproducible as well, so you could literally say, 3, 2, 1, and it's down, right? So low bandwidth, extremely low bandwidth, did require auth, but if you found this condition in the right server, it's dead, right? And CDNs aren't going to block this, WAFs aren't going to block this. You're going to get by scot-free, no problem. So it's important to look for even these types of conditions, and be, obviously be cautious in terms of, you don't want to bring anything down, and but keep in mind that if you did, is it reproducible? That's really the question, right? So to go back, if you ever ran into a WAF or something that was supposed to block this, try to figure out, could I just bypass it using just quotes or comments or something like that? Really effective technique here. So again, with the limited resources, right, I could run into a CDN, I could run into a WAF, I could run into an IPS. They're not going to be blocking this particular type of logic because it's supposed to work this way. I'm not sending malicious requests, I'm sending the same requests that I should be making. And I'm not sending a lot of them, and I can wait a long time. Or I could send it from multiple systems if they were allowing me to log in from different sites. Right? So if they weren't restricting me to a single login per user, which is a common vulnerability in a lot of web applications, we could do this from a lot of different sites all at the same time, right? And that would just, yeah, highly effective. So in terms of your bypasses, you need to fix your web app because your controls to mitigate this flaw, they're not gonna work. You need to fix the code and fix obviously the running as root. That's just bad. But even if it wasn't running as root, it probably still would have been. Oh my God. Cheers. Wow. Thank you, guys. Did not see that coming, so nobody in here told me about that. Anyways. Good times. Anyways, so the cons, right? It's this particular bug, very language specific, right? And not just that, it was application specific. But if you found a similar vulnerability in any app or any framework or anything, please talk about it, because this is the type of bug that like people die for. Like, this is great. Like, if I would have heard somebody tell me that you could bring an app to its knees in like a few hundred requests and it's reproducible, that's gold. So if, for sure talk about it. It required auth, it required, some access. It didn't require source code, but it did require auth, so it's just something to keep in mind. I'm just still, God. Anyways, it was good. It was good. All right, so what we did was we basically took all of these different attack vectors, right? And we didn't really cover HPing 3 because I figure you guys already know it and you can look it up, and there are plenty of other attacks. But what we did here was we really just put together a menu for anyone who's going to do a DOS, and you basically tell me, what are the knobs we can, change, right? Do you have a lot of bandwidth, right? Or could you use those vulnerable systems on the internet, right? And if you can't do that, well, maybe we disregard a couple of the attacks. Can you do recon? Yes, no. Do you have auth? We disregard that vulnerability. But if you have some flexibility here, you can expand or focus your efforts on certain types of vectors. If you can get source code to the application, there's tons of other things that might expand there, right? There's, this particular attack pattern would change, right? What comes into play? How do we do this different types of testing? And there's plenty of other vectors, right? There's plenty of other tools. This is no means a comprehensive list. This is where you'd basically start. This gives good coverage on a lot of tools that we've seen be highly successful in DDoS-based testing for clients who are really concerned about, can you bring my web application down? What would it take? How much effort? How much resources? It helps answer those questions. All right, so all of the stuff that we've talked about so far has been either direct or the reflective-based attacks. How do we make this stuff distributed? How do we really take larger scale? I want a botnet behind me, not just my laptop, maybe and a whatever. All right, so what do we need to do? We need to basically take all of this stuff that we're doing. We need to spin up either cloud instances or systems in our data center and basically give our attacks scale. That's in essence where we want to be. So what we did was we put together some tools to do this, and that's what we're going to be talking about now. So the first thing that we looked at was our different options in things like EC2 or Rackspace-based cloud, right? These guys, that's what they do. They have the ability to basically spin up as much computational resources. We want a piece of the pie, right? We want to be able to do, 1,000, 2,000, 5,000, 10,000 systems. And, in theory, they can do this. There are a lot of limitations here, right? We need to be able to do this type of test, push out that bandwidth, and we need to be authorized to do so, right? And their security teams would probably need to be in the loop on that, right? If you just spin these up and you just start launching, they're probably going to just shut you down. So what we've found has been really successful is building the relationship with your team and theirs. If you wanted to use cloud-based services, they definitely need to be in the know. And from there, as you work with them, things get a little bit easier. So this is this one tool that was released, and this is already online, so you guys can take it and run with it. The guys over at Rackspace, we found, were really, really good and really, really helpful when we actually wanted to go out and do a DOS. So there's one command here which would, in essence, allow you to spin up, 100, 1,000 systems, really, really easy. And specific to Rackspace, we're just including an identifier for the Ubuntu LTS 12 system, right, which is a pretty common based Ubuntu server where you could just install all of your attack tools on there, and then from there launch the attack. Again, you do need to get authorization to do this because you need to basically map out, all right, how many systems do you want? When do you want to launch the attack? So there's a lot of paperwork that needs to go on behind the hood. But once you get all that stuff out of the way, repeating it for a lot of different clients is really easy. So in addition to that, we wanted to basically cover, here's basically the rough metrics in terms of your capabilities, right? If you wanted, say, just a large number of systems, right, you probably want to go as small as you can go, right? If you want the fastest one system, you go down to the bottom, right? In terms of what we found to be successful, maybe going for not the smallest or the largest, going somewhere in the middle, you get the most bang for the buck in terms of the resources and being able to push out the most, with what you have, right? You're not going to go the fastest as compared to one particular node, but the bandwidth comparisons from a price perspective as well makes sense. So I'd probably go with, maybe 2,000 or so, flavor 4 instances over more of the 3 or the 8, right? Just depending, I found that those were pretty good. Maybe you go 5s, but 4s were pretty good. And most tools wouldn't require more than that amount of memory, right? The use case here in terms of the bandwidth is definitely something you're going to keep in mind. And how we conduct the test, is it going to be direct to the client, or are we going to go through an additional layer like Tor? And if so, are we running those end nodes? We'll talk about that. So we have, at this point, we have the capability to spin up the 1,000 or 5,000 or whatever scale system by just using a simple command here. And we've decided what we want to use, right? So from there, it's really just pushing out and running our particular commands in all of these different systems. So how do we do that? So the first thing that we wanted to do was to be able to do this in a really repeatable way. So what we did was we basically created an SSH key, pushed it to all of these systems, and we just used that to basically spawn out all of these commands. So we just add a quick item to our SSH config, and from there you can basically run commands on all the boxes, and it's not going to complain about host checks or anything like that. So that's exactly what we wanted. Next, the distributed command. This is what would run a, like the ID command on all the boxes. So this is something that we're going to be releasing fairly soon. It's going to be on our website. And in essence, what it allows you to do is you give it a list of IPs and a command to run, and it runs it on all the boxes. And you can either get the output or redirect it to dev null or whatever you'd like. So if we want to run the example on the bottom, the dos.perl command on Acme Co, we just send the lists.txt file, and it will basically just run everything on all those systems. And again, this basically assumes you can SSH these boxes without typing in a passphrase or something like that. It's all SSH keys under the hood. And the way that this works is it actually uses the PDSH utility, and which is basically just distributed parallel SSH client. And we just wrote a wrapper in Perl to basically make it a little bit easier for people. I think that that's pretty easy like this, rather than actually having to go in through PDSH and all that stuff. So hopefully you guys like it too. So this is the capability to run one command on multiple systems. What about the capability to do multiple times? Well, a multi-command would do that too, and this is something that we're also including in our toolkit. So the multi-command, we just give it the command we want to run, the number of times, and if we want to run it in a loop or not, just 0 or 1. Really, really simple. So from there, we get a flood on Acme Co, run 20 times from one box. And if we ran this in a distributed manner, on all boxes, right? Really, really easy. What about stealth? How does that work? Well, we have a couple options here, right? We can use end nodes or sort of the Tor exit nodes that are already existing, or we could spin up our own Tor exit nodes, right? This is really a question for your team and how and what the client basically would accept. If they're cool with you just using Tor exit nodes on the internet, then that's good enough. We'll just do that. If they really want it to be all your systems and they're still going to basically block your IPs, then that's something to just keep in mind. The proxy chains NG project, this is here at the bottom. This was actually really, really useful because what it allowed you to do was to specify a specific configuration for the instances of Tor that you're going to run on. Why is that useful? Because what you can do is you can spin up 10 instances or 100 instances or whatever number of instances of Tor you want and generate configs for what you want to test. And then have it run any command over all of those instances of Tor. So here's what it looks like. So we want to spin up 10 instances of Tor. We say Tor, or the multi-Tor.sh 10 instances, and this is going to create a configuration file for you. So the proxy chains config, and we're good. So from there, with that, you can say run all, and it would basically push this hash table, which is the hash collision-based attack, to all of the instances on one node on all your 10 instances of Tor. So with that, again, your Tor client is going to be connecting to the different Tor exit nodes in theory, and that would give you new IP addresses if you were using systems on the internet, or if you're using your own, it would just use the single and exit node that you're using. So if you're using systems on the internet, you'd basically be able to mask your IP address, and they wouldn't be able to keep up with blocking each IP because it's going to be changing frequently, and you're going to be spinning up and spinning down those Tor clients. So that's really, really effective and would work really well in a distributed manner. And this sort of puts it all together, right? This really just makes it really, really easy. So with that, one of the things that we haven't yet talked about, which is almost the most important piece, is how do we validate when we actually have a success, right? Is an Nmap scan sufficient to basically be able to say, this website's down, or is that maybe not enough? What we found in testing is we need to make sure the service is obviously up, but we also need to log in. We need to interact with the database. We need to make sure the website works. We need to make sure the application works as a normal user would expect it to. If I can't get the content that I'm looking for, I don't care if your website is up. It doesn't matter to me. I need to be able to use it like a normal user would. So we use a tool called HTTP, and with this, what we can do is we just give it the location, the URL, and it works just like ping, right? It gives us, all the response times, the errors, all the messages, everything we need. So obviously the website's working, right? Because we can get the page, get the content. Well, Apple's website wasn't working when they were doing their launch. Nmap said it was up, but you look at the site and it's not what a normal user would expect, right? And even with Akamai in front of it, this is not acceptable for a normal user experience, right? It's the content, it's the usability of the site, which is what the user cares about, and with that, what the client would care about, right? So their website's down even though it's up, right? It doesn't work this way. So what do we need to do to get better, right? There's a lot of things on my list. For everybody who's a pen tester, hopefully you can take this presentation and all the resources that we're going to release and go through all of that. We're also going to release a pen testing DDoS checklist. Here are the things to make sure you're going to get covered when you do a DDoS-based assessment to basically ensure coverage and depth for any security assessment. And this is something we want to start a dialogue with you guys. So if you have feedback, questions, things to make it better, let's start a dialogue on that. And you guys can absolutely provide insight and ways to make this better. For all the developers, we need to stress test everything, right? We need to really go back to what does it mean to build an application and really bang on every single input in unintended ways, in addition to the intended ways. Could your site handle 100 users, 1,000 users, 10,000 users? What are the limitations? And understanding where this thing scales and where it doesn't, right? Understand your application better than anybody, but also the things you didn't even think about. I found that a lot of universities, they don't really stress testing, right? This is something that I didn't see when I was at university. I'd like to see more universities do that, push that back to the developers, and then, later scale, we can also educate them about a lot of the security vulns. Response teams, they definitely need to be in the loop on a lot of this testing. So that would be great. When we do testing, we'll basically go and say, hey, are you guys seeing the type of traffic that we're expecting? Or are you seeing something completely different? Did you see when I'm spoofing these different IP addresses? Or did you see when I'm launching Solaris from this particular system? Or you completely not even have that insight, that visibility? So working with teams in a more white box scenario when appropriate before you get to the more sophisticated with black box. Because maybe that's the best bang for the buck. There's a lot of other things that we could cover here, but I did want to be able to take questions from you guys. So let's sort of open this up for questions. Question?
When you're talking about using Tor for
yes.
how did you affect the speed of your tests?
So for those particular tests, you do need to be mindful about the fact that you're not going to be like flooding the pipes, right? You're clearly going to be going for the application layer-based attacks. We found that we were able to not have any issue with speed performance based on what we were trying to achieve using Tor, right? For the specific attacks where we used Tor, didn't have an issue with the performance because we basically understood the menu or the attack menu here and mapped it back to what would be relevant for that particular limitation because we were very much aware of it. Any other questions? Alrighty, so we're going to be releasing all of the resources for this presentation on our website. So if you go to praetorian.com/DDoS/tools, it'll be there. And in addition, if anybody, you guys are, do pen testing, if you guys are looking for jobs, let me know. We're hiring, and I'm going to be here for the next couple of days. So yeah, with that, if you guys have any other questions, we're good. So thank you.